In problem 19, we're asked to verify that both of the following quadratic expressions are prime. And if you look up at the definition of a prime quadratic expression, it just means it can't be factored using integer values, nice numbers, -3, -2, -1, 0, 1, 2, 3, those kinds of numbers. So we're going to need to try our trial and error method that we've learned in this lesson and apply it to all the combinations for the coefficients that we have. And if none of those provide the correct factorization, then we say that the quadratic expression is prime. So for part A, what we're going to do is to look at the combinations of binomials that might possibly multiply to give us x squared minus 2x minus 1. So x and x have to go in the first slots. There are no other choices. The last slots have to be 1 and 1, and actually they have to be -1 and +1 because the product is negative. And so it wouldn't matter if I put +1, -1 here, it's the same thing. If I multiply this, I'm going to get x squared minus 1, which does not equal the quadratic that we started with. This is not a viable factorization. There are no other ways that we could try to factor this that would possibly work, and so we say this is a prime quadratic. For part B, 4x squared plus 2x minus 5, it's going to be the same kind of thing, but it's going to be a little bit more complicated. So what I'd like you to do is to pause the video and write down all the possible combinations that I could write as two binomials that might multiply to give me 4x squared plus 2x minus 5, and then come back and check your work with the video. So what I've done here is to write down all possible combinations for which the multiplication of the first terms would give me 4x squared, and the multiplication of the last two terms would give me -5. So you can see I started with 2x and 2x, so there's only two different combinations there. Doesn't matter if I switch the 5 and the 1 because the two x's are the same. But then the 4x and x I have to switch around, +1 minus 5, -1 plus 5, and then switch the 5 and the 1, +5 minus 1, -5 plus 1. So this is all the possible combinations. What I want to do is check all of these and see if I'm going to get a 2x out of that interior multiplication and addition. So here, 2x minus 5, I get minus 10x plus 2x, that's a minus 8x. That's a no. Here, it's 10x minus 2x, that's a positive 8x. That does not work. Here I get minus 20 plus 1 is minus 19x. That one won't work. 20 minus 1 is positive 19. That one's not going to work. Last one, -4x plus 5 is a plus x. That's not going to work. And 4 minus 5 is -x. None of the combinations that use integer values to factor this will work. Therefore, we say this is a prime quadratic expression.